This is the HVAC unit from the Scorpio, and here is the motor unit which runs and sucks in air from here. There is a filter here, as we all know. Last time I showed that filter, and it sucks the air in and pushes it through this place to the evaporator, and then the air is cooled and then it goes into the cabin. Now what we have done is that in the motor there is a thermocouple which has been embedded, which is a 2-point thermocouple taking temperatures at 2 points, and the thermocouple is the 2 points are connected to this box which does all the reading of the output from the thermocouples to convert it into the value that conveys the temperature of the 2 points.
Can I power it on?
Not now. Very quickly, I'll let you know when to power on. Similarly, we have put 2 points, 2 pressure points, one here at the inlet of where the air comes in, and another at the point where the air goes out. As you can see here. And this is a differential pressure transmitter which calculates the drop of pressure between this point and that point, and that also is then conveyed by this set of wires into this box, which does all the calculations in order to convert the value of the amperage that it receives here into the pressure drop amount, and then shows it into the graph. We have here the graph, which at the moment the motor is not running, so but still we have some data. As you can see, it's a time series data. The time axis on is on the x-axis. On the left you see the temperature graph, 0, 25, 50 degrees, etc. On the right there is a pressure in pascals, and you can see minus 400 to 400 plus 400 in pascals, and the red line is a pressure line, and which will indicate the drop when we start the motor running, which we'll do very soon. And then you have these dotted lines. The dotted lines indicate the 2 temperatures that are coming from the 2 points of the thermocouple. Right. Okay, now we are going to power the motor so that it starts sucking in the air into the HVAC system, and let's see how it affects the graph line that is getting created on this time series chart. That's every so often the graph is getting latest data.
9 seconds.
Right. So we are waiting for the. Yeah, we are waiting for the motor to be powered on.
Only now it's going to be connected to the battery.
Oh, okay. So you can stop it. Once the motor starts running, there will be a bit of a noise because of the movement of the air from the inlet to the outlet. So you have to bear with us. There you go. As you can see, it's now running. Sorry about that, the door is banging. And you can see how the pressure is rising there. And the temperature is also rising with the motor running. So, we will move this way. So what we will try is to see whether we can affect the change in the pressure, because as you can see the pressure is now again moving. It is visible now, it's getting settled now at a certain point. It's leveling off. However, we see there are two dashed lines in the temperature, but they are increasing gradually. And we expect the temperature to increase, but at this stage the pressure will remain level because we are not doing anything to the pressure drop at the moment. So yes, as you can see, it's leveling off gradually. So the pressure drop is about 150 pascals at the moment. That's what it's showing. And it's a constant pressure drop because it's leveling off. Now we'll try something. We'll try to cover this up by say about 33% and see what is the effect of that. There's a slight kink here, right? That's because of the fact that I put a cover here.
Yeah, you can increase it.
So let's slightly see the kink a bit better, or maybe you can take the video. Here the drop has increased and then again it's leveling off, right? Now I've covered it a bit more. Let's see whether we can see the second kink. Yes, the second kink is now quite visible because of the fact that I am not covering this much. Unfortunately, we do not have enough time to show the graph in a very good resolution.
100% probably.
Okay, now maybe I have cover 80%.
Another small.
You see another step there?
Yeah. Yeah, big.
Right. Now it has moved up quite a bit because I have covered much of it. So there is a big rise.
No problem.
So there is a big rise. And then it's again leveling off. Now I'll cover the entire thing. And we now expect a small rise, a smaller rise because the cover is, the amount that was not covered was very little.
Yeah, again.
So again you see, now it's going to level off.
Yeah, it is.
So the pressure is now, pressure drop has increased and it's now leveling off. So now we'll stop the motor for a while, and of course you have seen that the temperature is rising for both the thermocouples. And what we will do, we'll reverse the direction of the motor and see whether it goes down, the difference goes down, right? So can we stop it and then change the polarity? We have stopped the motor. The pressure has dropped to its original level almost, or slightly lesser. It's near the zero. It has dropped to zero. Yeah, because there is no pressure drop between the exhaust, the inlet and the exhaust. Okay, we have started it with a reverse polarity, and let's see what happens. Okay, it's leveled off at zero. Now let's start covering this up again. So let's see what is the result of the covering of the wire mesh.
Slight increase. Slight increase.
Looks like it, right? Okay, let's see what happens here. Cover this.
There is a surge. No problem. Now there is a slight surge. Not to that level.
Because I am covering the outlet. Cover it. Inlet. Now goes down in the opposite direction. So whatever we are expecting will happen, right? Okay, I think we have covered the ground. That's all. Is it clear? The graphs are clear. So we can also show the fact that we can hover the mouse over and see what is the real-time data we can easily capture there. So it's refreshing every 9 seconds. So that's why the graph goes off once in a while. You want to go the report? Yeah. Tabular report. What is what you have? Okay. So this is the tabular report that is generated every 9 seconds you get a record. Every 10 seconds you get a record. Yeah. Because we are transferring the data every 10 seconds. Okay, thank you very much.